Okay, Chapter 4, Section 2, the law of cosines. We're going to use the law of cosines to solve oblique triangles. Law of cosines is a little more complicated than the law of sines, but it's a nice formula that you can use. An oblique triangle is a triangle that doesn't have a right angle. The law of cosines is used to solve those in which two sides and an included angle are known, and those in which three sides are known. The law of cosines is given here. These are our formulas depending on what you're looking for. Notice that if you are looking for side A, you need to know side B, side C, and angle A. And if you're looking for side B, you need to know side A, side C, and angle B. If you're looking for side C, you need to know side A, side B, and angle C. Use the law of cosines to find the opposite side of the angle given. Use the law of sines to find the angle opposite the shorter of the two. And then you can also subtract two known angles from 180. So we're going to use a culmination of what we studied. The first one here says solve the triangle shown in the figure with angle A 120 degrees, side B is 7, side C is 8. Round the lengths of the sides to the nearest tenth and the angles to the nearest degree. So we're going to use the law of cosines to find the angle, to find the side opposite the given angle. The given angle is A, and we're looking for side A. Well, we know B, and we know C, and we know angle A, so we're going to plug that in to this formula. A is equal to 7 squared plus 8 squared minus 2 times 7 times 8 times cosine of 120. When I do my calculations here, I get A squared is 169, so A is 13. So I've used the law of cosines to determine that A is 13. Then we're going to use the law of sines to find the angle opposite the shorter of the two given. So side B is 7, angle B is across from that, so sine of B is equal to B times sine A over A. We plug in here, we find that this is the sine of B. Use the sine inverse and I get B to be 28 degrees. Now, if I know that A is 120 and B is 28, I can use that on the fact that a triangle's angles must add up to 180 to subtract and find that C is 32. So I've found all the parts to their triangle. We're going to use the law of cosines to find the angle opposite the longest side. Use the law of sines to find either of the two remaining acute angles. Find the third angle by subtracting the measure of the angles found in 1 and 2 from 180. So we're going to solve this triangle if A is 8, B is 10, and C is 5. Round angles to the nearest degrees. Because the cosine of B is negative, and B is an obtuse angle. B is equal to 180 minus 82, which is 98. Use the law of cosines to find the angle opposite the longest side. So when I plug in here, B squared equals A squared plus C squared minus 2AC cosine B. And then I move these over, move this over here, move the B squared over here. A squared plus C squared minus B squared equals 2AC cosine B. Divide by 2AC, plug my numbers in, I get 11 over 80. Cosine is negative 11 over 80. So since the cosine was negative, I know that my angle is going to be obtuse. So I get it to be 82, but I know that it is 82 degrees up from that x-axis, so that's going to be an angle of 98 degrees. Now I need to use the law of sines to either find one of the two remaining angles. So it's sine A is equal to A times sine B over B. So I'll plug in, and I find that sine of A is 0.7922, which gives me an angle of 52 degrees. Now that I know that angle B is 98 and angle A is 52, I plug into this formula to find that the remaining angle is 30 degrees. An application problem. Two airplanes leave an airport at the same time on different runways. One flies directly north, 400 miles per hour. The other plane flies on a bearing of north 75 of east at 350 miles per hour. How far apart will the planes be in 2 hours? So we plug in and we get 917 for B. We use the law of cosines. We're looking for, here's my problem here. One's going north, 400. One's going 350 degrees this way, 350 miles this way. And plugging in, we find that this is the B I'm looking for. I have 700 squared, 800 squared, because they're going to go for 2 hours. That's why this is 700 and this is 800. Cosine is 75 degrees. So I find that B is 970 miles. The planes are 970 miles apart. You'll also need to know Heron's formula for the area of a triangle. It's given here. Be sure you're careful as you plug in.